I welcome our next speaker, Alex Muller. He's the founder of Savvy AI, and he will give a talk on a secret topic. Alex, the floor is yours.
Okay, thank you. Hold on one second. Let me just do one thing here. I have to. Do you see? I'm sure you all see it now in full screen, correct?
Yes, now it's full screen.
Okay. So, so I wanted to do something totally different. At first, I was thinking about talking a little bit more technical, and then I realized that, like, there's some awesome engineers in here, and that's not going to be my focus per se. But we have an issue. As an industry, we have a real problem. And the problem of our industry is, in many respects, there is a lot of people who don't understand data science. There are a lot of people in data science who don't understand data science. And as you probably already know, there are a lot of different layers. So the issue here is for the lay people, right? People who wouldn't even be able to, say, compile something out of GitHub. They have this vision that machine learning is a panacea, it can solve a lot of problems. And it's true, it can. But they also have a vision that it could also scare them and replace their roles and those other things. So what I want to do is take a moment and talk to all the people who are in the data science community and talk about the social aspect of data science and how to help people come along with you into the machine learning era. So if you grant me, I know it's a little bit different, but I think it's worthwhile that all of you kind of get a chance to think about it this way. Also, as many of you will probably do this kind of the way I do this. One, please ask any questions you want, whether technical, non-technical, I'm happy to dive into them. But two, if this is more of a side of desk thing, that's okay. If there's something I really want you to see on a slide, I'll point it out. But if not, just hear my voice, because, think of it as a different way of just kind of getting a different perspective. So look, you've probably seen a chart like this before in your past. You've probably seen somebody say, oh, look, there's an evolution happen. And the evolution is something that we in the industry all understand, right? We know what analytics are. We know those are the statistical data sets that are historical. We know how to use machine learning to make predictions. But one of the things that's really important is from predictions to automated decisions. Now, what you all think of as machine learning, generally, what that often entails is making a predictive model that takes a bunch of inputs, model features, has a target, predicts a target, right? And that's fantastic. That is the definition of machine learning as everyone understands it. Predictions are not decisions. What the rest of the world outside of the data science community thinks of when they think of machine learning is they think of something a little bit more like this. They think of the evolution into automated decisioning, into the thing that actually thinks and makes a decision. So let's take the course of how you think of getting from point A to point B. When you're thinking about it in the old school way, I don't know how, you're probably all a lot of young people on this call, so you may not even remember paper maps, but there used to be a time where the human brain had to do all the thinking on how to get from point A to point B. You had to look at a map. You would then act as your own AI engine when you would say, like, if I pick route A, I'm going to predict a certain time, and I pick route B, I'm going to predict a different time. And then fast forward 15 years later, and Google Maps had, and at least it would give you a time prediction, and you would still have to then pick your route and execute each drive. This is the difference. This is giving you a prediction if I go this route, but it's not actually making the turn-by-turn decisions. Fast forward 15 years after that, and depending on how you feel on self-driving cars, I got it, tell you whatever you want, but the reality is, for many people, there is some level of self-driving car that's here, and that is the car making the decision. And that is the fundamental thing that people think of when they think of AI and machine learning and data science. They think of an automation into the decision. And that has to then change a mindset. This is where it's interesting. You guys, this whole industry the men and women of this industry, they are defining how it works, but they're leaving huge gaps in explaining if it works and why we should be comfortable when it works and how it has to change the thinking. So when you think about it now, for those of you who work on a software product development team, even today, outside of the machine learning context, normally it works like this. Somebody in strategy, business, product says, I want a new feature. I want a faster checkout on my commerce page. Great. And data analysts go and say, well, okay, what are the ways we can make checkout faster? Well, I've looked at the behavioral data, and if my checkout button is in the top right-hand side of the screen, that usually saves 30 seconds on session time. But when I've tested it in the bottom right, it adds 15 seconds of session time. So that is what I'm using. I'm using my historical data. And I'm treating everybody as a monolith, and I'm not really thinking about nuance, but I am actually analyzing the data. Then I come up with a decision. Okay, checkout button should be on the top right-hand side of the screen. And then the coding team will go and code it that way. And everybody feels great because the strategy is faster checkout. The data analysts came up with a theory and the development team deployed it. Now, move to a machine learning world, in which case the machine learning world is radically different. The one part that is the same is you need to define a strategy. So your strategy may be reduce session time, right? And now you're tracking session time, you're going to reduce it. But now is when the machine learning comes in and says, for person A, put the checkout on the top right side of the field. For person B, put it at the lower left-hand side of the field. And in this context, now you get to something interesting where the machine learning starts to learn where the checkout button should be, automatically decides it, and there's no coding because the machine learning, because the thing was coded in the beginning to be dynamic, and the thing is using the machine learning to adapt the code dynamically. And now what you're doing is you're getting machines that learn to change pages in the way they all want to make it so that you don't have to sit there and run through standard sprint cycles. And one of the interesting things is that process is being embraced by people. Many of you probably work already at the companies that are already embracing this process, but many of you also do not. And for the companies that, for the freelance people out there, for the people who are working and saying, I can solve this problem with machine learning. I can reduce hundreds of thousands of lines of code by using a machine learning model to come up with the solution here instead of, endless case statements or if-then statements or whatever. Great. But how do you get people on board? Because one of the things here is as a machine learning, as you all know, the thing is hard, right? There are many, 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 many steps. And unfortunately, the vast majority of the people in this industry think all of their steps actually, but they're only the first two. They're only the data science steps, and they are only the model evaluation steps. Some of you may also be like, well, I'm productionizing ML and I have ML ops going. Great, so you're doing the other two steps. But predictions are not decisions. And if you're going to build a system that actively decides, do I go with option A, B, C, D, E, F? And do I make that decision based on one or more models? Now you're building a multi-model system with an objective function that you must also apply controls to. And I can show you an example at the end of our talk on a mechanism like that. But the point here is think of all the additional steps. Now you got to add controls, and the controls have to be human readable. That's because if you're saying, oh, hey, I'm going to do this, like let's go back to more of a financial one. I'm going to offer somebody a different loan, and I'm going to offer person A loan A, which I think they're going to prefer, and person B loan B, which hopefully the model thinks will prefer. But no matter what happens, you're going to have somebody in your company in compliance, and regulatory, and risk saying, I don't care what the machine learning model thinks. I know for a fact this also has to be true, i.e., if the credit score is below a certain number, you must hide the low interest rate loans. And because humans also need to be comfortable with modeling, you need to add that. So think about all those layers. And then you get the data. It has to be recursive. It has to continuously learn. And ultimately, that is a lot of additional functions outside of bringing in the data set into a predictive model, making a Jupyter notebook, and coming up with models that you're going to produce. And I think this is the thing. A lot of the data science teams, they love to deep dive into the endless permutations of data analysis, and that's great. But it leads to our big problem in the beginning, which it means it fails to deliver. 90% of models, and I know this to be true, never make it into a production setting being used in a production way. I'm sure everybody on this call has built lots of models that they've never pushed to a product team to use in a recursively real-time way. And maybe they use it more of an analytics way, maybe they use it more of a proof of concept, and that's great, and that's part of the evolution of the industry. But it also means that the layperson, who is the manager, who is a guy or a woman who controls your salary at the top of the company, is saying, where is the results? Where are the results we're really looking for? Not the theoretical results you tell me about, but the results in our actual live product that says, I am actually saving money. And again, if you worked at one of these companies, you're already seeing those results. But if you're not, if you're in every other company, you're seeing a lot of this. So real quick, for some of you who are interested in our product, we help solve these problems, but I don't want to spend a lot of time talking about that. So how do you help, now back to the social aspect of this, bring people on board? Well, what I want to do in this presentation is give you some ways of communicating. So think of this as, come back to this later, download it yourself. And if you find yourself, as you all will, even though you have your expertise in data scientists, you still have to help explain why your expertise is useful in solving a big problem. Here are some tools you can use. First, you can talk about intelligence, and you can start to explain things like the following: how causality leads to predictive models and how predictive models lead to automated decisioning. And, in all reality, when you're explaining this, this works a lot like biological intelligence. Causality is like our experience. Predictive models are like us thinking about our experiences and coming up with different ideas. And then the automated decisioning is just making a choice. This is very international. I'm going to think of this more like, picture a goalie in a World Cup soccer game. And, the causality data he's seen is watching these players from around the world, Mbappe, Messi, Cristiano Ronaldo, whoever, kick their penalty shots. Then he thinks, well, I've seen this guy go to the right 9 out of 10 times, so that's his predictive model. And then he makes a decision he's going to dive right to try to stop the ball. This way of explaining will be very useful when you're saying, but these are all the components I need to make our software work right. So building with intelligence. The other way to explain it is in a pyramid. And a lot of managers like this really is the event-driven data, which is a causality, underpins everything. This everybody already on this call knows. Obviously, you need good data, clean data to come into predictive models that will be useful. And at the peak is using the automated decisioning. And intelligence that isn't used is useless. Like if you do not drive decisions from predictions, you're not doing anything. Really understand that. Every time you show somebody a prediction and they see that prediction and they do nothing, or the output's prediction and the software does nothing, you have done nothing. And I can't stress that enough, because again, that brings us to the problem of the industry where 90% of models sit on shelves. So one way to help explain the base of that pyramid is to explain what causality data is. And basically, causality data, as most easily understood by everybody you would talk to, is the idea that there is a cause and effect. And what does that mean? There is a cause and effect. Sorry, hold up. And what does that mean? You have profile data, you have contextual data, you have behavioral data. These can cause an outcome. And then you are tracking a decision point, and then you get an outcome, right? So the example back to the person kicking the penalty shot, the person's thinking, of they're usually favor one foot, they usually favor one side. It's a high pressure situation. Their decision point, they go to the side they favor. That's the outcome, right? That's the cause and effect. Do you have causality today, right? If you are talking to your prospective clients, if you are looking at your data set, and if you often have to ask the question, the answer is probably already no. One of the big problems that we have done in data and in data science is we have built almost all of our analytics for human consumption, which means that a lot of things are aggregated, things aren't specifically detail event driven, and they do not have the cause and effect relationship at each event. Event-driven architectures are relatively new, and they're being driven by the data science community. And one of the most frustrating things that you will find in this industry is that you will go to people who will have invested tens or hundreds of million dollars into data lakes and data warehouses, only to find that all that historical data is not event-driven. Profiles, even though transactions may be stored at the event level, profiles are overwritten, so people don't know exactly the state of the user in the time they made that specific decision to buy that product. And now you actually do not have data that's good for machine learning, does not embed its causality, and hundreds of millions of dollars of data that were used for human analytics is now worth zero for machine learning. And now you got to convince people to start over in some of their data collection process. And that isn't always fun or easy. When you're explaining predictive models, right? Using your causality data can make predictions. Great. This is something that when you're explaining this, I'm not even going to go into a lot of detail here. There is a lot to do with modeling. Sometimes the people in the data science community go way too deep into mathematics when trying to explain things to people who, quite frankly, algebra is a challenge. And so one of the big things here is how to get to explainability of a prediction without having to talk about complex mathematical terms like root mean square of errors or, R squared or any of the other error, heteroscedasticity, F types, P types, all that stuff. You can't explain any of that. What you really need to do is break it down more simply. Like we predicted, this probability of add to cart, and here are the contributions into that prediction. Some predict part of that contribution is the person has been a repeat purchaser. So basically looking at the model features, but coming up with really simplistic ways to make people feel comfortable that the predictive models make some sense. Now, modeling is more than prediction. Sometimes it's the causation versus correlation. And one of the things is this is super confusing. Most people, when they think of the word correlation, implicitly feel they're thinking of the word causation. And as you all know, not all things that correlate are causal. Sometimes they work because of something that is independent of that relationship. And making sure that you can explain the difference between causation and correlation so that people don't get the wrong understanding of what's actually driving the prediction is really, really, really important. Also, the other thing that's really important is knowing that predictions aren't perfect. And yet, one of our clients said this great. He doesn't need the thing to be right. He needs it to be more right than the average person. And that's also how to explain it. You are competing with human experience, and there are sometimes humans are great at certain things, but models can on average be more right than the average person. And if you can do that, you win. That brings us to automated decisioning. When you're thinking about automated decisioning, I remember what I said before. A prediction is useless unless it's used to make a decision. And the best kind of decisions that use predictions are automated ones that can run in real time, thousands of times a second. Think about a self-driving car, right? Every time it turns its own wheel, it's making an automated decision that is much faster than the human's perspective. So when you're thinking about it in that context, you're thinking about, okay, so I have my predictive models, my decision options, and my other factors, which could be controls. They go into an objective function, and then it picks option A. This should be the easiest to explain to somebody, because this is how we actually work. Take our experience leads us to make a prediction. If there's some guidelines or rules in place that we must follow, we'll apply them, and then we will make a decision. Having said that, using this intelligence is not always easy. You are going to find roadblocks to this. So let's go through some of the roadblocks and let's think about ways to unblock that. First, they don't trust it, the data or the models. Almost every company I've ever worked with for the last 30 years, when you ask them the state of their data, and I'm talking Fortune 50 companies down to startups, they always say it sucks. They always say it's dirty, it's not clean, it hasn't been cleansed, it has a problem, I can't trust it. Well, if you can't trust the data, you can't trust the models. Because it's such a dismissive and easy thing to say, oftentimes it stops projects right there and leads somebody else in the industry, more like the data warehouse companies, to be like, great, more data projects. Problem is, I promise 5 years from now, we'll get to that ML project once we have really good data. Now, there are a lot of different ways to unlock that, but right now there are companies making decisions on the data they don't trust. So one thing we could do is you could add things like guardrails, apply the human rules to the data set and the models such that the models then can work. And if they're working within the tolerance, then they can work and it makes sense. So, and one of the things here, and it solves that by saying, how to ensure AI doesn't go wrong. There are so many stories right now in the industry about where AI has made a bad decision and done things. Like a great example is the Amazon example that trained on its hiring data, and it ended up training on the fact that if the word said a woman's sport in it, because there was a low correlation between female engineers that they ended up hiring, the model trained and learned that the word woman was a negative weighting for the prediction if somebody would be hired. And that was obviously clearly what nobody wanted. And when they figured that out, that was problematic. So the one way they could do that is by setting guardrails, like ignore and do gender references in a resume. That would be a good example of a guardrail. Using intelligence, when you're using intelligence, one of the things is they don't understand it, right? And this is like, this RMSE, this is something you guys know off the back of your hand. It's the most simplistic thing in modeling. And yet go explain it to somebody who hasn't ever seen this before, and you're going to get a whole bunch of confused looks on it. So the thing that solves this is explainability. And I don't mean like complicated explainability. I mean like basic explainability. And that would be like an ability to look at any prediction and say, here are the components of the prediction. This is why I predicted this. Sometimes that's very, very, very difficult. I know that in a lot of top models, it's almost impossible. I know there are a bunch of startups going after it. I know our product does this as well. But the point here is, if you have some level of explainability, if you can explain why your system made a prediction, if you can explain why your system made a decision, it helps people. It means like they don't have to understand the math of the model. They just need to understand why it kind of made sense. Now, in this, you may also find a third challenge. The third challenge is, and it happened to us recently, one of our clients had recently gone in, they had thousands of records of data, and they put it into our system, and it started making decisions. And as it made decisions they weren't quite in agreement with. They had a mental model that says if they charge $2 for an entrance, they should drive a lot more entrance than if they charge $5. So you had to buy a ticket. A $2 ticket means more people should buy than a $5 ticket. What the model said is there was almost no difference between $2 and $5. That's what the model actually said. The actual behavior of their users showed there's no difference between a $2 ticket and a $5 ticket, that anything under $25 was pretty much treated the same. That did not jive with the mental model of somebody in that company. And that was problematic. And so you have two solutions here. Number one, trust the data and tell the human that, they're wrong. Number two, work with the person, rebalance the data, because sometimes they may not be wrong. Maybe they had just a limited data set and they know for a fact human intuition means something else. So then you can work with them to things like rebalance data. But the point is, you have to work with your clients to help them understand, or work with your teams, how to make this understandable, even when it doesn't quite fit the mental model they have. That third part is the most challenging. The last one, when you finally make this thing work and work well, then you get the scariest thought of all. Well, isn't that my job to make this decision? Isn't this thing just going to replace me? And then this one is the hardest to answer. And it's probably one of the biggest frictions we have right now deploying a lot of our software. We need to start helping people elevate themselves out of micro tactics that can be dominated by AI and into macro strategies where, quite frankly, AI is not going to solve the problem. When you have no data on something, or you're deploying a brand new product, or you're trying something new, at some level, machine learning as we currently know it isn't going to really solve that problem. And that's what you want. You want people to start using their creativity, because AI doesn't solve that problem, typically speaking, and let AI take the micro tactics of what content to put where, or which checkout button to use. And I think if you can talk to them correctly and saying you're still providing the strategic identification, you're letting AI just optimize within that strategy, then I think this is more like expressing, how you always wanted to have somebody working for you? Now you're going to have just an AI agent working for you as opposed to a human working for you. And that can still solve that need for growth. So as I said, using intelligence is an issue. You have huge obstacles in that they don't trust it. And to solve that, you can things that add trust, like guardrails, say like, hey, you can define any boundary you want, and please do, and the software will use it. They don't understand it, right? In which case, not understanding something, most people don't understand how their internal combustion engine or the electric engine motor of their car works. And yet they totally trust it. And so I think they don't understand it doesn't actually matter, as long as you can prove that it's doing something that makes sense, something that's intuitive. And you can always prove something that's intuitive with some layer of information. And then the third, they think it can replace them. Well, in this case, some people's decisioning or actions will be replaced. That is the nature of progress throughout human history, right? We used to have 80-90% of our population farming, and now it's less than 2%. At the end of the day, people change roles. And the point of AI is to change people out of micro decisioning roles and into more macro decisioning roles. And that should be a good thing for human society. So ultimately, when you're making software that learns, you really need to convince people that the machine learning is here. The strategy drives automated tactics. It's critical to help people come with you on this journey, because they have to embrace how intelligence works. All right, I am going to stop there and look at the chat. All right, I don't see anything in the chat. Are there any questions?
Yes, everyone, please speak up.
I know
or
it's quite
post it in
different
the
for
chat.
you all, but I figured, you probably had enough of formulas.
I have a question.
Absolutely.
My question is regarding the explainability. Isn't explainability or even trust to the model or data is just some kind of let's say miracle or psychological effect for human. Explaining. Human usually often do very non-rational decisions, but human never judge other humans for non-logical decisions. You can hire a secretary, and then on the second day, this secretary will do some crazy things, and nobody will judge. But if it happen with model, it will be said, this is very bad. So I'm asking this first question, isn't it just a psychological moment? And second thing, if it is, maybe we should go with the way how human brain is working. We never explain to ourselves our decisions. We have a special model for that in our brain. So maybe we need to have just a complex model to make decision and a very simple model to explain it.
Yeah.
And this is not directly the same.
Yeah, no, I totally agree. A lot of people so I came from a bank. A lot of people in the banking industry right now are using complex modeling to come up with like price points on interest rates. And they use like what they call, strong AI to come up with the most optimal price points. And then they use weak AI to analyze the decisions of strong AI to come up with an explanation. Use a regressive model to be like, okay, that's a little bit easier to explain. So I want to talk to your first point. It is exactly right. There is have you ever watched those American police movies from the 70s? And the guy goes, I have a hunch. Do you know this word hunch? And what is a hunch? A hunch is a prediction that they cannot explain, right? So we humans do this all the time. This is our hunch. The problem is a trust problem. Let's say you talk to somebody who has a hunch, and back to the police example, it's their first day on the job as a policeman, and they have a hunch that guy stole, the car stereo. You're like, I can't trust your hunch. You've done this one day, but now you talk to somebody who's been doing it for 30 years. They say, I have a hunch, right? Oh, I believe you. You've had many years of experience. You've been successful. So the answer to explainability is trust first. If you can prove trust, you don't need to explain very much. If you can't prove trust, then what would you do to the person who's it's the first day and they have this hunch? You'd say, explain to me why you have that hunch. Oh, there was this guy and the window was broken in the car and he scraped and there was blood on his shoulder, like whatever. Like he would explain all the different things. And you're like, okay, now I believe you. So the idea here is we are in this industry where humans make a decision on who gets paid. And so you want to get paid for the data science. You want the projects to get green lit. You want to be able to do this. So that's why you could say you have to start with being able to explain, because unfortunately, in almost every scenario, we're all the first day on the job, right? We're bringing this new industry to make decisions where before the decision was an if-then statement. If FICO score is greater than 700, show the lower interest rate. If it's less than 700, show the higher interest rate. That was explainable. Now, in the future, we could say like, no, actually, you can give a higher interest rate even to the person with a good credit score because they're going to may not care. Like, that's my point. My point is, once you have trust in your models, you have to prove a lot less. But until you have trust in your models, you have to prove how it came up with it. Now, if you're using super complex models, there are techniques to derive explainability there are two forms of techniques to derive explainability. One is you can do another model that kind of models the model, and that's great. The other, which is what we call simulated runs, and where you say, okay, I've taken your data and I've rerun it through this decision engine, and here are the decisions it would have said, and here's the fraud it would have caught based on the new model. And that would also do trust, right? So it would be like, this is how this thing's going to behave. Does that answer your question?
Yes, almost. Just, is it good to use some other models to explain some more complex models? Because it's not exactly the same explanation.
So
Because it's
yes.
like kind of fooling a little bit.
Oh, absolutely. Sure. But here's the thing. What are you actually presenting to the user that, and remember, I'm talking about the CEO of your company, the VP, the CFO, whoever, who, even if you're like, I'm using this other model to model this model, at some level, they don't care. What they would say is, the best way to say it is, I can predict this model's behavior would do X in Y scenario with 99% confidence, right? If you wanted an asterisk at the bottom and say the confidence interval of your understanding the model's behavior is X, you could do that. But they don't want to see a second model. They want to see a simple page that says, this is the behavior you can expect.
Thank you.
Okay. Okay, so somebody here said, and aren't we trying to make a decision? Well, let me go. So it is like, I think models to convert. Oh no, that's the other one. And aren't we trying to make decisions which are the highest probability to? Can you give examples of other reasons for saying to use our models? Great. All right. First, Hojum King. I don't know the correct way to pronounce your name, so I apologize about that, Mr. Kim. So yes, oftentimes when you think of a decision, you have option A, B, C. And the whole point in our system is doing this exactly that way. We predict option A, we predict option B, we predict option C, we predict the potential result of those. We pick the best one. But sometimes you have more than one model, right, in a decision. You want to increase the revenue and decrease the probability of fraud, right? So you predict the revenue of a transaction and the probability of fraud, and you want to pick the middle ground that is to make the right one. So the finance community has lots of ways to think about that, where you're like, okay, my goal is X and I want to increase X. Now, in commerce, you can increase sales. And one of our clients right now is using it to determine the right price of an automobile. We have another client that is using our software to do things like determine the right media mix of ads. And it's doing those things where it's less about the model, but more about the entire decisioning service. But yes, the industries are just, anytime somebody needs to make a decision. But here's the other way to do it. Our litmus test for whether somebody is going to be a good client for AI in general is, do they have a data-rich problem? Is it operationally relevant? This is really important. Does it actually matter, the problem they're trying to solve? And does it reoccur a lot? Someone has a problem that they're trying to solve, but they only solve it once a year. They're not going to embed an AI model engine to do it. But if they're trying to solve that problem 10 times a day, that's going to be very important. So operationally relevant, data rich, and reoccurring often. And any scenario that uses that is a good time to use them all. Any other questions? Oh, great. I'm glad that helped. Emre?
Hi, sorry, I didn't want to. So I'm actually a professor of operations management technically. So this data decision driven making is something that unfortunately I lived for better or worse than a lot of times. I also come from a finance background. I worked in muni bonds. I was curious because one of the things that I actually do to help talk through clients through decision making and kind of supplementing with AI is that technically, and one of the things you talked about was trust, was I said that the best way to develop trust is you're not always going to understand why the AI makes a decision. The better way is to think about it working with a partner, right? It's there to facilitate your decision making. It's not there to replace you. And what you'll find more often than not is that if something seems odd at first, it's simply just saying that there are maybe things you haven't considered yet. And it's the bigger point is hopefully it can open your mode of thinking, right? Because if you stick to a very strict model, as you mentioned with, your customers aren't as price sensitive as you may think, it's less about saying you're wrong or you're right. It's more about saying, first, try to think about the options of things you can do. And then once you start talking to them in that sense, they get, I find, at least a lot less defensive about a lot of things. Because ultimately, at the end of the day, trying to explain a complex model to someone, no matter how much you reduce it down, it's just usually going to be, unless you kind of go to the very, very, very basics, it's just going to be tough. Whereas if you really want to talk, as you were saying, like making it a partnership, one of the key components of building a partnership is that time component and letting them kind of work with it.
Yeah. And so one of the things I often do, I use the word automated decisioning, but in many cases, like in the case I was talking about automotive, it's automated recommendations.
Yeah.
So our system will recommend what to do with the price of a car. We recommend you increase it 2%. We recommend you decrease it 3%. And then what happens is something very, very interesting. If our recommendation is in line with the salesperson's thinking, they love it. Now they're like, I thought that was right. Now I feel really right. I'm going to do it. If our recommendation doesn't line up with their thinking, then they're like, usually they're like, oh man, something's weird. I wouldn't do that. Let me now look and consider this problem more carefully. Oh, I don't agree because of why. Okay, well, that's not a bad thing, right? That we made the salesperson think 5 more minutes on something to still justify a decision. So this is, and I'm sure you all do this too, when you're driving and you've got Google Maps and Google Maps is giving you roughly the direction you expect it to go, you feel pretty good about it. But if it's all of a sudden taking you somewhere you expected not to go, then you'd be like, oh, let me look at that. Is there traffic? What's the cause? Do I ignore it? And sometimes you do ignore it. Sometimes, like, you know what, I think I know better, and I think that's great. I think that human machine learning partnership is fantastic. And so I love the way you said it. Many of our clients think of these as recommendations, not decisions. But yes, completely. That's a great approach to building trust.
Thank you.